Assalamualaikum warahmatullahi wabarakatuh. In this video, we'll continue learning on integration by part. Let's see part 3, which is involving inverse trigo. So please take note that any function that involve integration of inverse trigo, we should use integration by parts. Let's see example 1. We have integrate inverse tangent x dx. So as I mentioned before, we need to use IBP. So you only have one function here, which is inverse trigo. So this stands for I, which is inverse trigo. Therefore, we can say that this is equal to u, because you only have that one function there. So since this is equal to u, therefore the rest of this is equal to dv. Therefore, dv is equal to dx. So from u here, which is inverse tangent x, let's further differentiate this. Du over dx is just 1 over 1 plus x squared. And let's find du, which is just cross multiply this. Therefore, du is equal to 1 over 1 plus x squared dx. And let's look at our dv equal to dx. Therefore, let's integrate this. V is equal to x. So now we have finished finding du and also finding v. So let us proceed to step number 3, which is using the formula for IBP. So let's do this. Integrate inverse tangent x dx is equal to uv minus integrate v du. So let's do this. U v minus integrate v du. Okay, so multiply all of this here. So this is the new function that you need to integrate. The first part here is ready, so just cut and paste it here. And let's focus on the second part. So we can see that this is integrate of x over 1 plus x squared. So we need to use substitution method. So how should we do this? Let w as equal to your denominator 1 plus x squared. Let's further differentiate. dw over dx is just 2x. And then dx is equal to dw over 2x. So what should we do here is, let's substitute. Your denominator now is equal to w. And let's substitute your dx. dx now is equal to dw over 2x. So now you can see that you have a common term. Let us cancel out the common term. And we see that we have a constant. Let's take out 1 over 2. So let's rewrite back the first part here. And let's focus to integrate the remaining function here, which is 1 over w dw. So now integrate 1 over w. This is just ln modulus w. And don't forget to write plus c. Please take note that this is not your final answer yet, because you have this in terms of w. So we don't want w, we want the original variable, which is x. So let us back substitute this function here. So your final answer is x inverse tangent x minus 1 over 2 ln, and let's substitute your w, 1 plus x squared in modulus plus c. So that is the end for example 1. So please take note again that if you need to integrate something with inverse tangent, even though it is alone, we need to use IB.